Today we'll be looking at scalar or dot product. The dot product of two vectors, say vector A and B, if we have vector A and vector B, the dot product between these two vectors is given by A dot B. So A dot B is a dot product of these two vectors A and B, and this is equal to the magnitude of vector A multiplied by the magnitude of vector B multiplied by cos theta. So that if these are two vectors A and B, we can as well find the angle between the two vectors, right? So using change of subject formula, we can have our cos theta to be equal to, we'll divide both sides by the magnitude of vector A times the magnitude of vector B. That is, we will have vector A multiplying vector B, that's a dot product, divide by their magnitude, which is the magnitude of vector A multiplying the magnitude of vector B. So from this, we can be asked to find the angle, which is theta. Theta therefore will be equal to the cos inverse of this vector A times vector B, divide by their magnitude of vector A and the magnitude of vector B. So from this, we are going to look at some question on dot product. So our example 1 here says, what is a scalar product vector v dot vector w of the two vectors v equal to 0, 5, minus 2 and vector w equal to 3, 1 and minus 2. So these are two vectors, and the question is, what is their scalar product? Remember, scalar product is also known as dot product. Scalar product or dot product can be used interchangeably. So this vector v that's equal to 0, 5, minus 2 can also be written as 0i plus 5j minus 2k. Then w can be written as vector w, which is equal to 3, 1 and minus 2 can be written as 3i plus, since it's 1j, we'll just write j, right, minus 2k. So from this, our v dot w, vector v dot vector w, which is a dot product or the scalar product of the two vectors, is equal to, remember, we are going to be multiplying this component by component. So we are going to pick the I component in vector v and multiply it by the I component in vector w, and that applies to the rest of the components. So we are going to have this equal to 0 multiplied by 3. That's for the I component. We'll add it to the j component. This is 5j multiplying 1j. That is 5 times 1. Then we'll add it to the k component. The k in the first vector v is -2. The second one in vector w is also -2. So we are going to have -2 times -2. So finally, we're going to have 0 times 3 giving us 0, plus 5 times 1 giving us 5, plus -2 times -2 is 4. So the scalar product of vector v and vector w here, represented by v dot w, is equal to 9. And so this is how to find the scalar or dot product of vectors. Scalar or dot product of vectors. Let's look at another example. For the second example here, we are to find the scalar product of the vectors. Vector A is 3i minus 7j plus 2k, and B is equal to 2i minus 2j minus 3k. And the options are given to us to pick the correct option after we have solved it. So for this particular question, remember, scalar product is represented by this. Since it's vector A and B, we are going to have A dot vector B. And this is going to be equal to vector A. Vector A as given to us in this question is 3i minus 7j plus 2k. We'll multiply it by vector B, which is 2i minus 2j, then finally minus 3k. So from this, we are going to multiply component by component. We'll have 3 multiplying 2. So we are going to have 3 multiplied by 2 plus minus 7 will multiply minus 2, minus 7 times minus 2, then plus 2 will multiply minus 3. So we have 2 times minus 3, and that's equal to 3 times 2, we have 6, plus minus 7 times minus 2 is plus 14. 2 times minus 3, we have minus 6. So we have 6 plus 14 giving us 20 minus 6. So that our final answer is 14. And this corresponds with option D. So the scalar product of vector A with 3i minus 7j plus 2k and vector B with 2i minus 2j minus 3k is equal to 14. Let's look at another example. For our example 3, if vector A is equal to 2i plus 2j plus 3k and vector B is equal to 5i plus 2j plus 7k, we are to find A dot B. This is again another question in scalar or dot product. The options are given as seen here. You can pause the video, attempt it, then you return to check whether your answer is correct. Alright, now let's solve it. So A dot B, which is the required task for us to do, is equal to vector A, which is 2i plus 2j plus 3k. multiplying, you have vector B, which is 5i plus 2j plus 7k. This equal to, component by component, we are going to have 2 multiplying 5, 2 times 5, plus 2 times 2, plus 3 times 7. Two times 5, we have 10, plus 2 times 2, we have 4, plus 3 times 7, we have 21, and finally that's equal to 10 plus 4 is 14, 14 plus 21, we have 35, corresponding with option A. So the dot product or scalar product of the vectors A equal to 2i plus 2j plus 3k and vector B with 5i plus 2j plus 7k is equal to 35.